Good morning, dear students. We have already discussed about the light is penetrating from one medium to another medium in the last video in wave optics. And now we are going to discuss about the light penetrating from denser medium to rarer medium. Okay. So in wave optics, there are different types of light penetration is there from medium to medium. Okay. Last video that we have already seen about this is air, which is a rarer medium, and this is water or a glass, which is a denser medium. Okay, so the light is penetrating from a rarer medium to denser medium. So as you can see in this blue color is a denser medium, right? So this is what we have discussed in the last video. And there is a small comparison between the rarer medium to denser medium and denser medium to rarer medium. Okay, so in this, the blue shaded portion in the first diagram that it shows the light is penetrating from rarer medium to denser medium, and how the wavefront which is created in here, how the refracted wavefront is there, what is medium 1, what is medium 2, everything explained in the first diagram. The second diagram, as you can see here, the darker portion represents that it is a dark portion. Dark portion represents that it is a denser medium. The light is penetrating from denser medium and it is going out in a rarer medium. So that here you can see angle of incidence is greater than angle of refraction. In this diagram, you can see that angle of incidence is lesser than angle of refraction because the speed of light is decreasing when it moves to rarer medium to denser medium, and the speed of the light is increasing. That is why it moves away from the normal in the denser medium to rarer medium diagram. Okay, this is incident wavefront, this is a refractive wavefront. More or less, these two diagrams looks very similar. Only the medium changes. Because of that, the refracted wavefront and incident wavefront, everything will give the changes. Okay, so when it comes to here, case 1, the angle of incidence is greater than angle of refraction, which I already told you. Light rays bend towards the normal when it travels from rarer medium to denser medium. So V1 will be greater than V2, where V1 is the velocity of the denser medium, V2 is the velocity of the rarer medium. So V2 or rarer medium, the speed of light reduces, so V2 value will reduce, V1 value will be greater. In case 2, the angle of incidence is less than angle of refraction. Light rays bend away from the normal. When it travels from denser medium to rarer medium, V1 will be less than V2. So what is the conclusion? Velocity in rarer medium will be greater than velocity in denser medium. And this is what we are going to see by using the Hygen's theory. Okay, so denser medium to rarer medium, in refraction, any point of incident, the wavefront interacts with boundary. While it's interacting the boundary, at that point, every point, the secondary waves will be formed, and these secondary waves will have some different velocity. So velocity in denser medium is less than velocity in rarer medium, that is V1 will be lesser than V2. So if you see in the next video, this is the model diagram for you to understand how the wavefronts are created. Okay, so the light which is coming from denser medium, this is a denser medium, incident ray which is coming out here. In denser medium, the secondary wavefront is very less, a small radius. As you can see here, this is a denser medium. The blue colored portion, dark colored portion represent the denser medium, so that the wavefronts are smaller and it is nearer. When it moves to the rarer medium, what will happen? The wavefronts, it can move faster, it can move freely, so that the wavefronts which is created is having large radius. Okay, so you understand at every point. Can you see at every point? This is at every point the secondary wavelets are created at every point. Okay, this is a denser medium, this is a rarer medium. So when it comes to here, denser medium to rarer medium, if the light penetrates, this is the incident ray. As you can see here, this is incident ray. This is incident wavefront. Last diagram that I have explained that how the incident ray is coming as a wave, because Hygen's principle, we are considering the light as a wave. So if it is considered as a wave, the wavefronts are straight in here. So if it is straight in here, when it moves from denser medium to rarer medium, it moves away from the normal. Away from the normal means the radius will be, the secondary wavelength radius will be greater, so that this length will always increases. So okay, so the first point of wave where it reaches here, second point of wave reaches here like this, the wavefronts which is increasing over here. From B to C, it reaches the time taken, the distance it reaches is V1 T time. Okay, so here when the light ray from A to E in the rarer medium, if it goes, means that is the second velocity V2 into T. So this is a medium 1, this is medium 2. So V2 will be greater than V1. This is refracted wavefront, this is incident wavefront. Okay, the explanation is given in here. To prove the Snell's law, consider the two triangles ABC and AEC, which we have already taken for the previous derivations. It is similar to that of a derivation, that is BC by AC, and we will substitute the BC value V1 into T, that I'm going to explain in the next slide. You can see here, this is the explanation which I gave you last video. Okay, the light is coming as a wave, and this is a wavefront, how the secondary wavefronts are created, and what are all the things that it's explained. It is the similar thing. For the first case, we are considering this angle of incidence is greater than angle of refraction. So V1 will be greater than V2. And second point, angle of incidence is less than angle of refraction. So V1 will be less than V2. So velocity in rarer medium will be greater than velocity in denser medium. So medium 1, it is incident ray comes and hits here, incident wavefront. It is similar in the diagram. So here, triangle ABC. What is ABC? A, B, and C. In this triangle and triangle AEC, these two triangles are considered over here. So if you consider the sign of angle of I, it is opposite by hypotenuse. Opposite by hypotenuse means it is BC by the common point AC over here. And a similar way, sine R, if you consider that, it is opposite. Opposite what is AE by hypotenuse AC. Okay, AE by AC. So we know that Snell's law, sine A by sine R. So similar to this here, as you can see in the previous explanation, BC by AC into AC by AE. AC will get cancelled, so BC by AE will come. Similarly, here also BC by AE will come. What is the BC value here? BC value, it is V1T. So we are substituting the BC value instead of BC, V1 into T instead of BC. And what is the value of AE here? V2 into T. Okay. So instead of AE, we are substituting V2 into T. So what will happen? T and T will get cancelled. What is the leftover? V1 divided by V2. Okay. So V1 divided by V2, this will be the Snell's law, which we can consider over here. As you can see here, this is the C by N1, C by N2, similar thing which we can discuss over here. Here, in this condition, when the light ray penetrates from denser medium to rarer medium, V1 value will be less than V2. That is what we come to the conclusion. And this is case 1 and case 2. And special cases is there. What is a special case? Angle of incidence is less than, this we already know. The special case is if angle of incidence is equal to critical angle of critical. If in this case, refracted ray, if it is 90 degree, so in this case where it applicable, the total internal reflection. In this case, there will be no refraction will happen. Instead of that, the angle, critical angle, incident angle is more than the critical angle, means that in total internal reflection will happen over there instead of refraction. So in this condition, angle of incidence I equal to IC, where this angle of incidence is greater than, can you see this? This is greater than the critical angle. This is 90 degree. There, instead of refraction, total internal reflection will happen over there. So where IC is equal to critical angle. This is the critical angle. So refraction, it is more than the critical angle, means total internal reflection will happen. So this is the condition that we can explain for the same case, which is because we know the total internal reflection, the condition is the light should move from denser medium to rarer medium. So in the second case, you can see here the light is moving from denser medium to rarer medium. Okay. So the light is moving from denser medium to rarer medium means, so if that angle, if it's more than the critical angle, total internal reflection will happen. Okay. So go through the video once again. You may, if you find it any difficult, go through this video once again. Okay, you will understand better. Okay, the rest of the thing we will see in the next video. Thank you.